Okay, welcome back, ladies and gentlemen. We're going to go ahead and talk about how to rearrange tangents, cotangents, and sine equations so that we can solve for the angle and the direction on these vector problems that we're going to be faced with in the future. So we have to first think about order of operations. When we're rearranging an equation for order of operations and we want to isolate a certain part of this equation, what we're going to want to do is we're going to want to move everything else to the other side. So we can take this first equation, the tangent of 12 divided by, or equals, take the tangent of 12 and it equals the opposite over 18. So let's just write that out. Tangent of 12 equals the opposite over 18. And what is tangent? It's just another function like multiplication or division. And we just use a calculator to do that. You can use our scientific calculator for that. And you can just type that in and make sure that we're always in degrees. And so here we have those functions, sine, cosine, tangent. We can take the tangent of 12, and that gives us 0.21. If we were working in radian, which we're not, we'd get something else. So it's always important to make sure we're in degrees. So let's go ahead and do the same thing, the tangent of 12. And we see it's quite a bit different, right? So if you're like, Mr. Foreman, I think my answer is wrong, it's probably because you are working in radian and not degrees. So please always make sure that you are working in degrees. All right. So there we have our sine, our cosine, and our tangent. So when we come back here, we have the tangent of 12. We know what that is. It's a real number, but we don't really want to put that in right now. We will later. We have this opposite over 18. We want to figure out, in this case, our unknown is our opposite. We want to figure out what that is. So before we do that, we need to rearrange our equation, and it's just some simple algebra. If we look at this, we have opposite divided by 18. We can actually pull this over into our railroad tracks. I love it, more use of railroad tracks. And we want to get the opposite by itself. We want to get O by itself. So how do we get O by itself? How do we get rid of 18? Well, remember, A divided by A equals 1. 21 divided by 21 equals 1. So those cancel out and we're left with 1. These cancel out, we're left with 1. How do we cancel out the 18? If we're dividing it by 18, well, we want to multiply it by 18. So here we have O, our opposite, times 18 divided by 18. These 18s cancel out, and all we're left with is our O up top. But remember, whatever we do to one side of our equation, we have to do to both. So we multiplied the right side by 18, so we need to multiply the left side by 18 as well. And we're left with 18 times the tangent of 12 equals our opposite side. So now all that's left to do is to plug this into our calculator. So we'll take 18 times the tangent of 12. Close our parentheses. And that's going to be the length of our opposite side of our triangle, 3.8. 3.8. And so our opposite side equals 3.8. And if we were using this triangle, or this vector, this right triangle, as our model, we can go ahead and fill some of these in. If this is theta, if that's our angle, well, our angle is 12. Our angle is 12 degrees. There we go. Just write that here, 12 degrees. Put that in right here. And our opposite side, we just calculated that. And so what's the opposite side of the triangle? What's the side directly opposite of our angle? Well, it's right over here. So that is 3.8. We don't have any units right now, but it could be 3.8 meters. It could be 3.8 feet. It could be 3.8 meters per second. I'm just not getting any good contrasting color. This one might be a little bit better. 3.8. There we go. It's a little bit better. 3.8. And what else do we have? We had our 18. Where was 18 again? Oh, right. We're using the tangent, and it was opposite over adjacent, so the 18 must be our adjacent side. So here's our adjacent side. It's right down here. And we know that it's not, our adjacent side isn't this side. This is the longest side, and the longest side is always that hypotenuse. Could we go ahead and figure out what the hypotenuse is? Yes, we can. We just use the Pythagorean theorem, and that's 18 squared, or a squared, plus b squared equals c squared. So that's 18 squared plus 3.8 squared equals c squared. And we'll go ahead, put that in parentheses, and go ahead and pause the video for a second while you use your calculator to find the answer. And you should find, don't make a mistake like I did entering into my calculator, that our answer is 18.4 units. We don't know what it is, but this is 18.4. If we're using feet, it would be feet. There we go. All right, I just want to double check my answer because it's always important to double check your answers. So 18 feet squared plus 3.8 feet squared. I'll take the square root of that. And yes, I double checked my answer, and that is the correct answer. So that's how we can find the hypotenuse for that problem. All right, ladies and gentlemen. Well, I'll do one more for you. Actually, no, we'll do a couple more for you. A couple more. Because I want to look at some other problems that are a little bit more difficult. So if we look down, the next two problems also are going to be dealing with the tangent and the opposite over the adjacent. All right, these are all tangents, and we're looking for the opposite in each of them. So we're going to be multiplying by the bottom number, by the adjacent side. But if we look at the next three, these cosines, our order of operations are going to be a little bit more difficult, and that's because we're dividing. Okay, we're dividing by the hypotenuse, and we want to isolate that hypotenuse. So how do we do that? Well, let's come over here and just write our equation. Cosine of 32 equals 9 over the hypotenuse. Well, we want to get 9. We want to get rid of 9, so we want to get h by itself. Well, let's go ahead and get rid of 9. So here we have, how do we get rid of the 9? Well, we want to divide it by itself, and we can do that, but now we're left with this strange equation. We're left with 1 over h. And we could do that, but that's kind of confusing. So 9 times the cosine of 32 equals 1 over h. That's a little bit confusing. So what we can actually do is we can actually do something. It takes a little bit longer, but it's going to be a little bit easier. So the cosine of 32 equals 9 over the hypotenuse. We want to get the hypotenuse by itself. So what we can do is we can, let's move the hypotenuse over. Let's try doing that, because that'll leave us a nice whole number up here. So we'll multiply both sides by h. These cancel out, and we're left with h times the cosine of 32. Remember, that's kind of just a number, okay? That's going to be a real number. That equals 9. So now we're right here. We have two numbers multiplied by each other. We have h and cosine of 32. And how do we get h by itself? How do we get rid of the cosine of 32? Well, if cosine of 32 is on the bottom, actually, we have cosine of 32 is on the top. We want to get rid of it. We have to put the cosine of 32 on the bottom, right? The cosine of 32 divided by the cosine of 32 equals 1. All right? So those cancel out right there. And whatever we do to one side, we have to do to the other. So we divide this side by the cosine of 32 as well. And we're left with h equals 9 divided by the cosine of 32. And that's how we isolate for our problem. So we plug this into our calculator. We just take 9, and I'll go ahead and show you that. Let's do this. 9 divided by, let's put this in parentheses, the cosine of 32. And that gives us 10.61. So our hypotenuse is going to be 10.6 units of something. And we can double check. Remember, the hypotenuse is the longest side of a triangle. So that must mean this number should be larger than the other two numbers that we had. And what were our other two numbers? Or sorry, it should be larger than the other two sides of our triangle. It's larger than our 9, so we know that it's bigger than our opposite. So that's good so far. Seems like we're on the right track. All right. Well, that should help you a little bit with rearranging these equations where you have an unknown on the bottom of one of these equations, right? Of 9 divided by the hypotenuse, where that variable is the divisor. It doesn't seem right. All right, the word is escaping me right now, guys, but I want to show you something really quickly here. Really quickly. So let's clean this up a little bit. We'll leave our answer right there. Our original equation was cosine 32 equals 9 over h. If we're trying to isolate h and get it by itself, well, what do? We essentially just move these and switch sides. That only works when you don't have anything else. So go ahead and work on the math. Follow the math, follow the order of operations, and get some practice on that so you're comfortable with that for the future. All right, last thing, guys. Save the easiest for last. Well, it could be the easiest. All right. So if you look at these next equations, we know both sides, but what we don't know is we don't know the angle. We don't know theta. And so this is where we look at that operation again. So the operations we're looking at right now are sine, cosine, and tangent. What are the opposite or the inverse operations of those operations? The opposite of multiply is divide. The opposite of subtraction is addition. And the opposite of sine is arc sine. It's the arc sine. And it can also be written like this. Sine to the negative 1. That is the arc sine. And you'll see this a lot on calculators, but you might see this on calculators as well. And you just need to know that these two are the same. And we can take a look at our calculator right now, and we'll hit this inverse button. And the inverse of sine is arc sine. See? We see it's sine to the negative 1 right here, but in our calculator, it pulls it up as arc sine. And the inverse of cosine is arc cosine. Here, let's clear that out. It's arc cosine. And the inverse of tangent is the arc tangent. So we just have to understand that when we are trying to get rid of a sine, we have to do the opposite. And so we just do the arc sine. And it's really easy, okay? So if we're given a problem that says the sine of 20, and we want to get rid of sine, and we want to just end up with 20, well, let's see what happens. We want to find the arc sine of that. So we have the sine to the negative 1. So let's plug that into our calculator. Arc sine, and then in parentheses we put the sine of what's our real number? It's 20. 20. There we go. So the arc sine of the sine of 20, the arc sine and sine should cancel out, and our answer should just be 20. So let's see if that's correct. It is. So we effectively got rid of the sine by taking the arc sine. And we can do the same thing for the tangent. And the cosine, and and all of them. So yay. So let's do that. So if we want to go ahead and say we want to get rid of the cosine of 20, we want to take the arc cosine of 20. So we can put that into our calculator. The arc cosine of the cosine of 20 gives us 20. The arc tangent of the tangent of 54 should give us what, class? The arc tangent and the tangent cancel out, so this just leaves us with 54. There you go. All right, so let's put this into practice. Let's rearrange some equations, okay? So let's look at this very first equation, the sine of theta. Sine of theta. And we want to get theta by itself. That's our unknown. So how do we get rid of, or how do we isolate it? Well, we have to get rid of sine. And we just learned that to get rid of the sine, we have to do the inverse operation, which is, in fact, the arc sine. So we take the sine of theta equals 7 over 11. Just writing my equation out. I want to get rid of sine, so I need to take the arc sine of it. So arc sine. But whatever I do to one side, I have to do to the other. So I'll take the arc sine of 7 over 11. And in parentheses, there we go. The arc sine and the sine cancel out, and we're left with theta equals the arc sine of 7 over 11. So let's see what that angle actually is. We can actually diagram this. Let's go ahead and do that first. We're looking at sine. Sine is telling us the opposite over the hypotenuse. So here's our angle. What's the opposite side? The opposite side is 7. The hypotenuse is 11. Know that 11 is the hypotenuse. And so now we can determine what our angle is. We want to figure out what that angle is. And so we set up our equation. Our angle is the arc sine of 7 divided by 11. So let's just put that into our calculator. I am working in degrees. Always make sure you're working in degrees. I'm hitting the inverse because I want to talk about the arc sine. The arc sine of 7 divided by 11. Make sure that these parentheses are in place. And that gives us 39.5 degrees. So our angle right here is going to be 39.5 degrees. And you see how I'm labeling my diagram? It's always going to be important to label your diagrams just so you can refer back to it if you need to, and so other people can see your work. All right, and remember, theta is always measured in degrees. It is a measurement of degrees. And in this case, if this is east and this is north, we started out going east, then we went north, so this is going to be 39.5 degrees north of east, right? We drew our angle. We started down here at east and we drew it up north. There is how you can rearrange these equations and solve for theta. I'd like you to go ahead, rearrange these equations and solve them yourself. All this work is going to be on our file page in Canvas, and I'll pull that up right over here. If you go to our file page in Canvas, in Resources, in Vectors, Algebra, and Trigonometry, you'll have this Algebra Practice. So you can download that and get some more practice with algebra. And then there's also some problems that we'll look at later in the week, later next week, when we actually create our own vectors. But I'll show a video of that. That'll be my next video. So have a great day, guys, and I will see you next time.